Good morning students. Now we can Z transform. Z transform definition is x of z equal to sum of n equal to minus infinite to infinite x of n z power minus n. So this is the Z transform definition. It is used to analysis of discrete time signals and discrete LTI systems. Here z equal to r e power j omega. The another important term is region of convergence. The region of convergence is nothing but the x of z converges all the values of z. So converges is nothing but it attains finite value. So the Z transform is used to analyze digital filter design. Now we can see the problems. The Z transform of finite duration signal. Finite duration signal is nothing but causal signal and right-sided sequence. So this problem is given here. First write down the formula. Okay, now how many sequences you have it? The arrow represents the origin of the signal. Only 4. You expand the summation, you will get like this: x of 0 plus x of 1 z inverse plus x of 2 z power minus 2 plus x of 3 z power minus 3. So x of 0 is given as a 2, x of 1 1, x of 2 2, x of 3 3. Substitute all the values, you will get the answer like this. Now we can plot the region of convergence. You take the z value 1 2 3 till plus infinity and minus infinity. Similarly for the 0, if I substitute all the values, it attains the finite value except z equal to 0. So if you get finite value of this, it is region of convergence. If at what value the ROC is the x of z is not attain finite value, so it is the not considered in the region of convergence. So similarly, we have a second problem. It is non-causal and left-sided sequence. The same concept we have to use it. The next one, you have a both-sided sequence, causal and non-causal. The sequence is given here. Okay, now you take the arrow represents the origin. How many sequence you have, like that you write it in the right side, similarly in the left side. So x of 0 plus x of 1 z inverse plus x of 2 z power minus 2 plus x of 3 z power minus 3. Similarly in the left side, x of minus 1 z 1 plus x of minus 2 z power 2. So all the values is given here, you substitute it, you will get the final answer is this one. Okay, now you take all the values of z, substitute it in this equation. If this x of z attains the finite value, or for that values the z plane is convergence, we can have it as a ROC. So as per this, the entire z plane is the region of convergence except z equal to 0 and z equal to infinity. The next problem, x of n equal to del of n. So you know del of n is the unit impulse sequence. Okay, so write down the Z transform formula. Substitute x of n equal to del of n. So this is equal to totally 1. The definition is given here. So at n equal to 0, the whole signal is 1. So here no z term. The ROC lies entire z plane. Similarly, the second problem, x of n equal to del of n minus 2. Substitute del of n minus 2 instead of the x of n. So this can be written by using time shifting property. The time shifting property is stated here. So x of n minus n naught z power, if you take a z transform, z power minus n naught x of z. So here as per the problem, the n naught is 2, you substitute z power minus 2. Okay, as per the property. So the ROC lies entire the z plane. So by how the time shifting property used to apply for the z transform. So the next one, find the Z transform of the following discrete time sequences, also mention ROC. So x of n equal to a power n u of n. So the sequence is causal. Here u of n is a unit step sequence. The definition is given here. Write down the formula first. Then in the formula, the x of n can be replaced by a power n u of n. Now u of n is 1. What is the limit? 0 to infinity. You take power common, the n term is common, power you take it out. Now as per the, we know that this formula, power series formula, as the power series formula we can replace the above equation by like this. Okay, so x of z equal to 1 divided by 1 minus a z inverse. A z inverse is less than 1, so you will get modulus of z is greater than a. Either you can have this equation or this equation. Is it clear? Now you draw a ROC. The radius is a, you mark it as a, so the region of convergence lies outside the circle a. The next problem, x of n equal to minus a power n u of minus n minus 1. Okay, here write down the formula first. This is anticausal sequence. Now substitute x of n is minus a power n u of minus n minus 1. So u of minus 1 minus n minus 1 is equal to 0 for n is greater than or equal to 0. Now here you substitute it here, change the limit u of minus n minus 1. So this becomes 1 for, okay, this limits n equal to minus infinity to plus infinity. You mark it. So you change the this minus, take inside this one. Okay, now all the things have been happened. Now you apply the formula. You will get the final equation is this one. Clear? So the modulus of z is less than modulus of a. So if it is lies inside the unit circle. So the next problem, combination of the first one and the second one. That is combination of 7th problem and the 6th problem. X of n equal to a power n u of n plus b power n u of minus n minus 1. So you change the limit. If first one no problem, the second one minus infinity to minus 1. The minus power you take inside. Okay, now you use the formula like this by using the finite series formula. You apply this formula, you will get the final equation is this one. For in this case, you will get, that is greater than a means outside, less than b means inside. So the region of convergence is formed in the form of ring. Next you have one problem, 7 1 by 3 power n u of minus 6 1 by 2 power n u of n. So this is by you applying the linearity property, this problem is solved. So the first part, whatever the formula we can apply it. 7 1 by 3 z power minus n power n. Similarly minus 6 sum of n equal to 0 to infinity half z inverse power n. Here as per the infinite series formula you replace it. You take a LCM. Okay, from the first term you find the what is ROC. From the second term you find the ROC. You will get the region of convergences like this. Similarly, you come to the, if it is a trigonometric series, x of n is equal to 1 by 3 power n sin pi by 4n u of n. So we have to use Euler's identity for the sin pi by 4n. You write like this, e power j pi by 4n minus e power minus j pi by 4n divided by 2j. So now you write down the z transform formula, apply into the formula. So this is equal to 1 by 2j, you take it as outside, sum of n equal to 0 to infinity 1 by 3 power n e power j pi by 4 power n u of n minus 1 by 2j. Okay, you split and write it. After that, by applying the formula, that is infinite series formula, you will get this one. Then e power j pi by 4 modulus is 1. Now from the denominator you obtain the ROC. So you will get the ROC is modulus of is greater than 1 by 3. So you take LCM and you simplify, you will get the final answer is this one. So the next problem, similarly for the cos pi by 4. Cos pi by 4, by using the Euler's identity, you will get this one. As we did the previous problem, the same concept we have to apply it here. You write down the Z transform formula, you substitute it, split the summation, you will get like this. Then you apply the infinite series formula. From this you calculate the ROC. If you simplify this, you will get the final answer as this one. The next one, find the Z transform following discrete time sequence. Also mention ROC. This is b power modulus of n. So this can be written as b power n u of n plus b power minus n u of minus n minus 1. As we know that b power n u of n can be written as 1 divided by 1 minus b z inverse. This is for greater than b power minus n u of minus n minus 1. So this can be written as 1 divided by 1 minus b inverse z inverse. This is less than. So now combining these two, okay, this forms is in the form of ring. So till this, the Z transform part is over.